In this lesson, we're going to look at scientific notation and at metric units and how to do math with them. So, first thing we're going to review is steps for writing scientific notation. So here I have 4,500,000, which is a really big number, and I have a decimal of 0.00453. And we can take really big numbers and really small numbers and write them in scientific notation. This will become important later this term when we're working with very big and small numbers with things like Avogadro's number, acids and bases. So the way that you do this is you look at the non-zero numbers, the ones that aren't zero, and you figure out if you were to write them as a decimal between 1 and 10, what would they be? So the first one would be 4.5, and the second one that we have as an example would be 4.53. And that's just all your non-zero numbers written as a decimal, so there's only the first number of 4, which is between 1 and 10, and then the others go after the decimal. And then we're going to write times 10, and then we'll write an exponent that talks about where was the original decimal and where is your new decimal and how are they comparing. So I'm going to show you what that looks like. So we put our new decimal as 4.5. Let's see if it's going to let me do this. There we go. And the original decimal isn't written, but it would have been there, right? So we're going to count the spaces. 1, 2, 3, 4, 5, 6. And so we do 4.5 times 10 to the 6th. If you've got a number that's smaller than 1, then we add a negative to that exponent. So I'm going to put my new decimal in my number between, let's see if I can get it to show up for you. My number between 1 and 5. Or sorry, 1 and 10 would be right there. And then we're counting and we get 3. And because we went for a number smaller than 0, the way we show that is by including a negative. So this becomes 4.5 times 10 to the negative 3. Okay, so metric versus imperial. You're probably more familiar with imperial measurements like inches, foot, yard, ounce and pound, not so much stone. They do have those in England a lot. Pint, quart, gallon, miles per hour, and Fahrenheit. Those are probably units you grew up with. But in science, we use the metric units because this is what most of the world uses, and so it's just easier for communication if we're using the same. And they're also kind of easier because they're kind of a base 10 unit. So imperial really aren't. They're based on 12, which is an older system that was based off of counting off your fingers, and the joints of your finger became 12, and you just count them with your thumb, so 4 fingers with 3 joints, 12. But we now use the base 10 one, which is metric in most of the world, and you'll notice that they use prefixes here like milli, centi, kilo, and they use those with various units, whether it's length, weight, speed, volume. They use those same prefixes and they have the same meaning, only whatever unit they're attached to, they're referring to that type of measurement. So these are the 5 that I'd like you to be responsible for knowing. Don't worry about memorizing them per se, but just be familiar enough to know how to use them because you can use your notes when you're doing your quizzes and your tests. But I do want you to know how to use them. So for example, the kilo prefix, like kilometer, has 1,000 of the base units. So if I had 1 kilometer, that would be 1,000 meters. The centi prefix is 1/100th of the base units. So if I had 100 centiliters, that would be 1 liter. The milli is 1,000th of the base units. So if I have 1,000 milliseconds, that equals 1 second. Micro is 1,000,000th of the base unit. So if I had 1,000,000 microliters, that would be 1 liter. And nano is 1,000,000,000th. So if I had 1,000,000,000 nanometers, that would equal a meter. So we can use these units in a way to convert between units by unit canceling. So if you have an equivalent, you can turn it into a conversion, a ratio that's basically equal to 1, but it is 1 unit on the top and the other unit on the bottom. So let's say, for example, we know that 1 meter equals 1,000 millimeters. So that could be turned into 1 meter over 1,000 millimeters, or it could be turned into 1,000 millimeters over 1 meter. And basically both of those are 1. So we could multiply either of these by a number, and it would be just like multiplying by 1, but the units might be able to cancel in such a way that you get the units you want. So what you'll do is you'll select the equivalent out of these two in sparkly above that would cancel out the unit that you're starting with by putting it in the denominator, so that mathematically you've got your starting unit, the one in the denominator, and the units cancel. You keep the numbers, you still use the numbers, but since those units cancel, your new units will be whatever didn't cancel. So for example, if I wanted to convert 54 meters to millimeters, I would use the second equivalent up above. And I'd take my 54 meters and I'd multiply it by 1,000 millimeters over 1 meter, and that gives me an answer of 5,400. And since my meter unit canceled, I can put the millimeter unit as my final unit. Or if I wanted to do just the opposite and convert millimeters to meters, I could take my starting millimeters and multiply by 1 meter over 1,000 millimeters. My millimeters will cancel, and I would get 8.7 meters for my final unit. So the starting units, if they're repeated in the denominator, are going to cancel out, and the units that don't cancel will be the answer units. So we can do this with a lot of metric conversions. So if we were to ask how many kilometers are in 6,890,000 centimeters, the steps for solving a problem like this would be start with your starting number in units. So we write that down. And then find the equality that gets from the initial units to the base unit. So our base unit here is meters. We know that there are 100 centimeters in a meter. And then find the equality that gets from the base units to your final unit. We know that 1,000 meters is 1 kilometer. And then you're going to put the units you start with on the bottom of the ratio and the base unit on the top for the first step. And then put the unit and if you're not ending with meters, you'd put the unit you want on top and the base unit on the bottom so that that cancels. And then you'd be able to cancel units. So if we put that all together, we take our starting number and then we'd multiply by 1 meter over 100 centimeters, and our centimeters will cancel and we'll be left with meters. And then if we take our second one, we can do 1 kilometer over 1,000 meters. Our meters now cancel because we got meters on the top, meters on the bottom, and our final unit would be kilometers. So in our calculator, we would type in our starting number and then divide by 100 in this case and divide by 1,000 to get our answer. We can also multiply by 1, but whenever you multiply and divide by 1, it doesn't change the number at all, so I usually just leave those out in the calculation. And that's it.